Hi students, now in this video we will discuss about the molecularity of a reaction. What the molecularity is. Molecularity is actually a theoretical concept, right? So it represents basically the number of molecules that must collide with one another simultaneously so that the product is formed. Because we know when a chemical reaction occurs, when the reactants they change into products, for the reactants to convert into product, the reactant molecules need to collide with one another. Only then the product is formed. How many molecules collide simultaneously so that the product is formed? That's called as a molecularity of a reaction. So molecularity can be defined as the number of molecules that must collide with one another simultaneously so as to result into a chemical reaction. That's called as the molecularity of a reaction. Now a chemical reaction is of two types. Some of the reactions are simple and some are complex. Simple reaction is the one which can occur in a one step, right? So a reaction which occurs in a one step, that's a simple reaction, but some of the reactions they occur in a number of steps. Okay, so we call them as complex reactions. So simple reaction is also called as the elementary reaction also. Okay, these are the reactions which take place in a single step, in a one step, and some of the reactions they occur in a more than one step. They need 2, 3, 4, whatever, right? So they occur in a number of reactions, in a number of steps. So that's a complex reaction. We'll see how to find the molecularity of a reaction in a simple reaction and in the complex reaction separately. In a simple reaction or a elementary reaction, the molecularity is simply the sum of the molecules of the different reactants, right? Suppose we have certain examples here. These are the simple reactions. They occur in the one step, which means that these are reactions occur in one step. And from the simple reactions, we can just find the molecularity just looking at the number of reactant molecules here. So you can see here the 1. So the molecularity is 1. Here the number of molecules is 2. Here also the 2. Here the number of molecules is 3. So the molecularity is 3. Right. So number of molecules from the reactant side is equal to the molecularity of a reaction. But that's only for the simple reaction. If a reaction occurs in a single step. But now in case of a complex reactions, we know that a reaction occurs in a number of steps. So if suppose a reaction occurs in 2 or 3 steps or 4 steps, whatever is that, correct? So a reaction occurs in a number of steps, okay, and then you get the final product. The molecularity of a reaction, of a complex reaction, we can find from its rate determining step, right? The rate determining step we know is the slowest step. So if a reaction suppose occurs in 4 steps, and suppose the second step is the slowest step, so that means we can determine the molecularity from the step number 2, because that is the slowest step, and the slowest step is always the rate determining step. So that means in complex reactions, the number of atoms or ions or the molecules which take part in the slowest step, that will be its molecularity of a reaction. Let's take here an example. See, we have a reaction NO2 plus carbon monoxide. It forms the NO plus carbon dioxide. Correct? So as if there is a transfer of a one oxygen from NO2 to carbon monoxide, which forms the carbon dioxide. But the reaction does not occur in a one step, it occurs in a number of steps. And when we look at the mechanism of a reaction, the steps of this particular reaction, the steps are believed to take place in these 2 steps, right? So first one is, this is the mechanism, NO2 and NO2, that means 2 NO2 molecules, they form the NO3 first and the NO3 and NO, and this is the slow step, right? And second step is this NO3, which is formed in the first step. Now it reacts with the carbon monoxide, provides oxygen to it, and forms the NO2 and carbon dioxide. So the reaction actually occurs in 2 steps, right? First NO3 is formed, and then NO3 reacts with the carbon monoxide. So NO3 here is an intermediate. It is formed during the first step and is consumed in the second step. So it is formed during the reaction, consumed during the reaction. So NO3 is the intermediate. And what we find here, the slow step is the first step, that means this is the rate determining step, and therefore we can find the molecularity of a reaction from the slowest step. So first step here is the slowest step in this particular example. Therefore the molecularity of a reaction should be 2, because we find 2 number of reactant molecules, 2 number of molecules from the reactant side in the slowest step. Therefore the molecularity of a reaction is 2. And what is this NO3? NO3 is an intermediate here, because it is formed during the reaction, consumed during the reaction. So NO2 is a reactant, carbon monoxide is a reactant, NO3 is a reaction intermediate, okay, and carbon dioxide is a product, and also the anode. Now let's take the same example here. How do we find actually the net reaction? If suppose this reaction occurs in a 2-step, this is the first step and this is the second step, how we find the final equation? We add the 2 steps here, right? So if you add the step number 1 and the step number 2, okay, in this one you find NO2 and NO2, here the 2 molecules of NO2, then you have NO3 and carbon monoxide, NO3 and carbon monoxide here, and then what do you get from the first side? You get NO3 and NO, and the second one you get NO2 and carbon dioxide, and then we will cancel out the common ones, right? So you find here the NO2 and NO3, NO3 and NO2 here, we can find the cancel out, we can cancel out these one, and you get the net reaction is this one. You get the NO2 plus carbon monoxide formed with NO plus carbon dioxide. But the reaction is not a simple one, it's a complex, it occurs in 2 steps, and we know the slowest step is the rate determining step, and hence the molecularity is also determined from the slowest step, correct? Okay, some of the important points about the molecularity. See this, as I said, the molecularity is a theoretical concept, right? Okay, and the molecularity represents the number of molecules that must collide to form product, and that's why it cannot be the 0, negative, fractional, infinite, or an imaginary, right? Okay, it has to be positive. Normally we find that the molecularity is in between either the 1, 2 or the 3. Molecularity with more than 3, again that's not possible, because it's not possible for the molecules more than 3 to collide simultaneously and form the product, right? So these are some important points about the molecularity of a reaction. Okay, so hope you got the concept. Thanks for watching the video. See you in the next topic.